of this week's class. And before we get started, I'm just going to give you a couple of assignments. I'm going to tell you to make exercise 10 at home. Exercise 10 is, a very quick exercise to do, but basically all the entire explanation is in the theory overview, and it's really like more to see if you understand how these things work and where you need to look. But of course, don't immediately jump into this. It's better if you watch along with the video a little bit and then you get an idea of what's going on. But of course, if you think I'm confident, you can already start. Then question 11, I wrote it there too. It's more like a recap exercise because, well, we got some questions from students. If it was possible to have some extra exercises, especially on sign investigation and that kind of stuff. So here, this is a, fully free exercise to make. You can, of course, always come and ask questions if things are unclear there. But this is basically make this much the same as what we did last week. So basically you just make a sign table and you investigate the entirety of the function. Okay, so it's a recap exercise. So that being said, let's move to 12. If you missed it in the last video, well, you'll see that I've skipped question number 9. I'm gonna come back to it in this video. So just hang on and we're gonna have a look at it soon. So at question number 12, it's a fairly straightforward one. We ask you to determine the directional coefficient and the intersection with the x-axis and the y-axis. So in this case, you get y is equal to, so I'll make a, so y is equal to 2x minus 1. And for this, let's have a look at our base formula for lines or linear function, and our base formula is going to be ax plus b, where a is your directional coefficient and b is going to be, well, your y-intercept. In this case, well, don't start calculating anything of that, but like really consider what these functions mean. Don't worry also, like I wrote it a or b. If you saw it at alpha or beta or all kinds of other notations, it's fine, but this is just the one I use. But if you are more comfortable with another notation, it's fine. But basically what you need to have is, well, basically some kind of real number times the variable plus, well, a constant. Okay, in this case, let's have a look at it. So we're looking for a, and a is basically the one that's in front of x. So it's going to be, our directional coefficient is going to be 2, right? Okay. Let's have a look then for our y-intercept, and you can always look at b immediately, but how can you find a y-intercept in general? Well, the very easy thing to do is you're going to say, well, I'm interested in finding where x is equal to 0. What does my function end up being? So basically x is 0 and then your function for x is 0. You're interested in calculating that. So if x is 0, we fill it in our function, and what do we get? We can find that y is equal to 2 times 0 minus 1. Or in other words, when x is 0, y is going to be negative 1. Or in other words, if you really want to write it as a point, you get 0, negative 1, where this is your x coordinate and this is your y coordinate. So this is going to be your y-intercept. Okay, much the same for x. You have for your x-intercept. You do pretty much the same thing. Of course, you can immediately just look at b, because b in this case is always going to be a y-intercept for lines, so not necessary for other functions. It depends on how they're written. I should say that's probably more important. So in this case, what you do is you say, okay, instead of setting x to x, you say, well, we'll set y is equal to x. And in this case, what do you find? Well, if y is equal to x, you find that 0 is equal to 2 times x minus 1. Or, in other words, x is equal to 1 over 2, because that gives 0. So, meaning that when y is 0, x needs to be 1 over 2. So we can write it as a point again. So first our x coordinates, and then say y is equal to 0. And that's our x-intercept. You can do this for the other exercises. I think I'm going to put one more on the board. I'm going to do exercise D, just because, well, it's not necessarily a tricky one, but you just have to be very mindful of what you're doing. And actually what's written there is y is equal to negative 7. So now I ask you, what is a equal to if we respect this notation? Well, a is equal to nothing, doesn't exist. A is 0, right? So it means that we're dealing with a function that's flat, right? It's not going up, nor is it going down. It's just staying flat. Okay, so what's our b then? So in this case, it would be -7. Okay, let's try that then. So imagine x is 0. Nothing happens to our function because, well, there's no x to fill in, so y just always remains equal to -7. So you find your y-intercept at -7. Okay, and now when is y equal to 0 for your x-intercept? And here you have to be careful because here it says, if you want to fill that in, you get 0 is equal to -7. And there is nothing we can do to make this true. It's not possible. So that means that there is no x-intercept. Okay. That being said, maybe it's interesting that you think about what does it mean for the function to look like this. Okay. All of that being said, let's move on to other exercises. Here really the idea is that you get familiar with these A and these B. What do they do? Well, the A, maybe I can draw it once out. So the A is going to determine how steeply you go up or down, and this B is going to just determine where you go through. So our function here, in this case, well, you can think of function transformations again. Y is equal to x. So we made it more steeper and we moved it down by 1. So we're going to end up with a function that looks kind of like this for 2x minus 1. Okay. Let's move on to the next exercise. And here we get to exercise number 13. And it's another exercise on linear functions. And we have to read through and we have to make sure that we don't miss anything. So it tells us a linear function has a directional coefficient of -3 and traverses the point -4, 1. Determine the functional notation for this line and calculate the x-coordinate for y is equal to -2. Okay, so what do we know? Well, we know that we're dealing with a linear function, so let's write down, well, we already know we have a linear function, so we have something that looks like this. Okay, the other thing we already know is that it has a directional coefficient of a is equal to -3. So we can update our knowledge a bit and we can say, okay, y is equal to -3x plus b. And the other thing we know is that we know that it needs to go to the point where when x is -4, y is equal to 1. Okay, so how can we use this information? Well, we can fill it in. We can say, okay, y is 1 when x is -4. And then this b needs to make sure that this equation is true. So what do we get? So we get 1, and here we get 12 plus b. So when is that 1 equal to 12 plus b? When b is equal to -11, meaning that we can update all of our knowledge and we can say that y is equal to -3x minus 11. So that's going to be our functional notation. Okay, so that's what I want you to do in question 30. Really think about all of this and digest it, and then we'll move on to question 14. And here we're doing much the same. Here the only difference is we're not giving our directional coefficient immediately. We're now given we're given 2 points. But that's not a problem because, well, we know what we can do with it is, well, we can say A is actually just the difference between 2 points and their coordinates. Or in other words, y2 minus y1 over x2 minus x1. If you want to know why this is true, I'll refer you to the lecture, but basically what you're doing is you're just abusing the fact that the line goes through 2 points like this, so you can kind of get, well, and the directional coefficient stays the same, so you can calculate this line over there. Okay, so we know this, and again, we know also that y is equal to ax plus b. Okay, so we'll have a look at 14, question A. And here we know that when x is 0, so for our function 0, so this means x is equal to 0, y is going to be equal to 5. Or in other words, we can write this down as 0, 5. Okay, that's great. And then we can call it, we can call it our x1 coordinate, and this is our y1 coordinate. Let's put a point here so it's clear. So it's a coordinate system here. And then the other thing we know is that our function is, okay, just a second, PowerPoint is busy apparently. So when our function is 1, y is going to be, so when x is 1, our function is going to be 7, or in other words, 1, 7. Okay, so first things first, well, we're very interested in finding this a. And this a we can now find because, well, we have 2 points given, so we can say, well, we have another value for x and another value of y that are linked for our function. So we can fill it in and we can say, okay, a is equal to 7 minus 5 over 1 minus 0. Or in other words, a is 2. Let's update our knowledge and we find that y is equal to 2x plus b. Okay, now we still want to find that b, but that we have already done once, right? You just have to fill in a point and you can uncover b very easily. So let's fill in maybe our easiest one and we say, okay, when y is 5, x needs to be 0, so this needs to make it true. So in other words, it means that b is equal to 5, meaning we can find our final solution, y is 2x plus 5. Okay, I recommend that you try to make exercise 14 the ones at home. Okay, then let's move on to question number 15. And here we're going to deal with parabolas. And basically what we ask you here is to write our parabolas in vertex form. And vertex form is a very nifty form if you're interested in finding the upper or the lowermost point of a parabola. So the vertex is this part over here, or if you have an other shape, it's this part over here. So that's the vertex. So the most negative part or the most positive part, right? And it means like when we can rewrite our function as fx is equal to, and here of course you can just give it different names, but here I called it alpha and beta so you wouldn't be confused because this is not necessarily the same a as before, plus beta squared plus gamma. And our vertex is going to be at minus beta gamma. So the idea is really that you just rewrite your function as follows. And here you have to mess around a bit with your function. So let's try that once for c. And I do c because a is pretty straightforward. You will see it's pretty easily, everything starts falling away once you follow through the steps. But c is a bit more tricky. So y is equal to 2x squared minus 3x plus 7. Okay, so how to start at this? How can we get this to this? Well, maybe first thing we can do is recognize that here in front of x, there's no variable over here. There's no number written. So we want to get rid of the number in front of x. And this we can do by just bringing out 2. So we can rewrite it a little bit as such. We can say 2 times x squared minus 3 over 2x plus 7 over 2. Okay, we got a little bit closer, but I can feel you're not convinced yet. But just here in front of our x, here, because if we square it, well, what would you get? You get something of this kind of x squared plus 2 beta x plus beta squared. Well, you see that this x squared is by itself, and that's good, that we have so far. Okay, but now we see that, well, we want to rewrite it as x plus, well, a number and all of that squared. And as I wrote over here, that means that we are going to have some in-between part that looks like this. So this we can always make work in the end by just adding or subtracting a number. But this one is much trickier because we want all of our x's to be contained within this square. So we need to be sure that all our x's are there. So basically, and you have to think about this a little bit, you need to think about how can we write this as well a complete square. So you write x, and then you want this to be true. And how do you get that to be true? Well, basically you want to uncover this beta over here. So we know it's going to be negative because otherwise there's no way of getting a negative sign over here. And then we know that it is going to be 3/4 and all of that squared. Okay, so we're much closer over here, but I hear you thinking, yeah, but Arne, what you just did over there, that's not true because, well, we still have this plus 7/2, and this is not going to be 3/4 squared, it's not going to be 7/2. And you're exactly right. So let's work it out what we have so far. So this and this so far are not equal to each other. So we can say, okay, this is going to be equal to 2 times, and we get x squared minus 3/2x. Okay, great. So far we've done well. So it's the same as what we had before, and we get here plus 9/16. And again, here you have to be very, very careful because this 9/16, as you know, this alpha that we identified here before, so this is going to be our alpha, well, it doesn't have an impact on our gamma. So this thing over here, well, we need to work it out. So we get 2 times x squared minus 3/2x plus 9/8, right? So this is just a way of rewriting this thing. So this is equal to that and all of that, but it's not equal to this over here yet. Okay, so now I ask you the question, okay, so what's the big difference between, well, this thing and what we had before? Because, well, it's not going to be exactly the same thing, right? So in this case, well, it's x minus 3/4, so we get here that it's 9/16. If I didn't make a mistake, yeah, sorry, I made a mistake. So it's here 3/4. No, that's good. 3/4 is good. Okay, so in that case, what do you need to do? Well, you need to make sure that these things match up to what you had before, so that we can say, well, this is truly equal to it. So then you really ask yourself the question, like, okay, what's still missing here for the equation from this one over here? What's the big difference? And in this case, well, you could say, well, what the big difference is you have 9/16 there. And in this case, well, we need to add up some things to it, and we need to say that if we add actually 47/8 to it, that we're gonna make it equal to each other. And how do you see that? Well, in this case, well, you add 47/8, you add that to the other thing, and you will see you will end up with the same thing. So now we can write this entire thing out, and let's see if it's truly the same. So you get 2 times x squared minus 3x plus 9/16 plus 9/8, because it's still times 2. That's the big thing we have to be careful with over here, plus 47/8. And what do we want it to be equal to? Well, we want this to be equal to 7. And yes, this works out because 2x squared minus 3x plus 56/8 is going to be, this entire thing is equal to 7. So really the trick here is finding the one thing that you need to add up so till you make this entire equation true, right? So what's the gamma over here that's at the end that's left to basically take care of like the difference? And now all of these things are truly equal to each other. Of course, well, it's not equal to this anymore. So let me just remove all of that so not to confuse you. Okay, now we have written it in vertex form. All that's left for us to identify is our negative beta. So that means our vertex is going to be at 3/4 over here, negative 3/4, and at gamma over 47/8. Really try to do this a couple of times for yourself to really see how this makes sense. And really the idea is that you work it out and see, well, how can you make this thing over here, how can you match it up to the original 7 you had over there? Okay, so that for 15, I strongly recommend you to make 15D and see how you can, so 15D is recommended for home. Okay. Then we're going to make one more here on parabolas, and then we're going to go back to exercise 9 because I want to show you one extra thing. So 16. So we have a parabola, And we know a couple of things. We know that its vertex is at 1, 1, and we know that it goes through the origin. So that means that it goes through 0, 0. Okay, so this is great. For this, we can use our vertex notation. So we can say, okay, remember this is our vertex notation. Remembering this is going to be the top of the parabola. So we can say, okay, vertex is going to be at 1, 1. So it's going to be alpha times x negative beta, because this is going to be our beta value over here. So we need to find minus 1, because otherwise it doesn't become 1, plus gamma, which in this case would be 1. So this is our vertex coordinate. So we already know that our function is going to look kind of like this. Of course, not forgetting the square over here. Okay, what can we do now? Well, we can say, well, we already know a point. So we can say when y is 0, alpha times 0 minus 1 squared plus 1 also needs to be, this needs to work out. So what do you find? You get here minus 1 squared, so you find alpha plus 1 is equal to 0. Or in other words, alpha is equal to negative 1. So really with these notations, you have to try and distill as much information as you can out of it, and then you can always find your final equation. So you get here minus 1, x minus 1 squared plus 1. And this is going to be the final notation of your function. Okay, so this for this vertex notation, but there is another kind of notation that can be useful as well. And for this, I like to refer you to exercise 9 again. And now we're going to solve one together. And I would recommend you make exercise, so let me tell you, write it down here, 17, recommended exercise for home. It's basically the same thing as what we did here, but here it doesn't go through the origin, it goes through another point. So we go to 9 and we'll make exercise J together. So y is equal to 4x squared plus 4x minus 8. And you can convert this to vertex form very easily, but sometimes there's a quicker way, because, well, you see with these vertex forms, like sometimes here it's a bit messy, you really have to think about it, you have to make sure that everything works out neatly. If you can factorize, there is an easier way. So let's see if we can factorize this. So let's find our roots for this equation. And here you're just going to have to trust me that we're interested in finding where this is equal to 0. And our discriminant, let's calculate one. We get 4 squared minus 4 times negative 8 times 4. And all of that becomes 16 plus 100. How much was it again? I wrote it down. Give me a second. It is 128. So that gives you 144, or in other words, the square root of your discriminant is going to be equal to 12. So we can find our roots, x1, x2, and it's going to be equal to plus minus 12, negative b, minus 4 over 8. Or we're going to find two solutions. We're going to find negative, we're going to get negative 16, so over 8 is going to be negative 2, and here in this case we're going to add, so we're going to find positive 8, so 1. And this is the neat things about parabolas, because, well, they are parabolas, as I told you before, they are symmetrical, right? So in this case we get a parabola that goes here to negative 2 and 1, so it needs to be symmetrical through there, right? Okay, excuse me if it's not very symmetrical, but basically meaning, okay, let me try that again. A bit better. Meaning that, well, the top of this parabola, and, well, I know it's a cup-shaped parabola because, well, going back to our exercise, our A is greater than, our A is greater than, not greater or equal than, greater than 0. Basically, you mean you have a cup-shaped parabola. The other way around, well, for that I refer you to the other exercise we did earlier, and basically you'll see it's flipped. So basically what you want to use is that, well, this, because it's symmetrical, it means that the top of this parabola needs to be exactly in the middle of those two things. So that means between our two x coordinates, right in the middle. And what's a good way of finding right in the middle? Well, we'll just add them together and divide it by 2. So you get the middle of these two coordinates is going to be 1 plus -2 over 2. It's kind of like an average, right? So meaning that this is going to be at -1 over 2. Going back to our drawing, well, it kind of makes sense that our average would be here at 0.05, right? Okay, so meaning that we have found, well, where the parabola is going to be mirrored over, like that line. Meaning that this is going to be our x-coordinate of our vertex. And once you have the x-coordinate, finding the y-coordinate is just a matter of filling it in. So you already know that it's going to be at -2, and then our function evaluated at 1 over -2. And let's do that once. So this evaluated at 1 over -2, what do you get? You get 4 times 1 minus 1 over 2 squared plus 4 times minus 1 over 2 minus 8. Okay, and let's evaluate that, and we get that this is going to be 4 times 1 over 4, so 1, and here we get 4 times -1 over 2, so -2 minus 8. So in other words, it's going to be at -9. So in this case, you see that my drawing was quite off, like I should have drawn it much lower, but basically our vertex of our function is going to be at -1 over 2, -9. But at least it makes sense, on the same side. Okay, so converting it to vertex form is also good. You can work with it. There's other ways, like I gave you another formula all the way at the beginning, which was if you just have a normal description, your vertex is going to be at -b over 2a, and then for your y-coordinates, it's going to be c times b squared over 2a as well. So this is for when it's written as ax squared plus bx plus c. Then you can use this. If you can write it as well, basically write it, if you can easily find its roots, you can use this method, or you can write it as a vertex. That being said, I'm going to recommend you some more exercises for home, and that's going to be the end for this week. So for 9 recommended for home are exercise H, exercise F, H, I, and K. Okay, good luck with that, and I'll see you all next week on Monday or Tuesday. Bye.